Okay, solving quadratic trigonometric equations. So what is the difference between linear trigonometric equations and quadratic trigonometric equations? So when we look at these questions, right, sine x and or cos x, they have power of 1, right? But when you look at these equations now, you see that sine square, tangent square, cosecant square, right? So therefore they are, these are a little bit going to be a little bit different. So let's look at the first one. Sine square x equals 2. Again, we are looking for solutions between 0 and 2 pi. Okay, so first thing, again, we are going to isolate sine x. We are going to isolate the ratio. Then we need to take the square root of both sides, plus and minus root 2. Well, can sine be positive root 2 or negative root 2? No, right? Sine x graph is gonna go for or cos. The maximum value is 1 and minimum value is negative 1. So root 2 is around 1.4. So it is over 1 or less than negative 1. So therefore this one has no solution. Okay, so if you ever get something like this, sine x or cos x is over 1 and lower than negative 1, then there is no solution. But it's not true for tangent x. Actually, tangent x can be anything. It goes from the range of tangent x goes from negative infinity to positive infinity. Okay, but only for sine and cosine the range is between negative 1 and positive 1. Okay, let's look at the next one. So sine square x is going to be divide both sides by 3, 2 over 3. So sine x, then take the square root of both sides, so you get plus and minus square root of 2 over 3. Okay, now we need to write a ratio for related acute. So that's going to be positive root 2 over 3. Now we're going to do sine inverse. So sine inverse square root of 2 over 3. So we get 0.955. Okay, so beta is 0.955. Now let's draw our x and y axis and write the cast. See, this is telling you that sine x equals positive root 2 over 3 and sine x equals negative root 2 over 3. So then sine x positive root 2 over 3, so you get the angle that is in quadrant 1 and 2, right? 1 and 2. How about when sine x is negative, right? So then you get the angle that is in quadrant 3 and quadrant 4. So actually this time you get 4 angles, right? One of them is equal to beta, which is 0.955. The one that is in the quadrant 2 is going to be pi minus beta. So pi minus 0.955 gives you 2.187. So the angle that is in quadrant 3 is going to be pi plus beta. So pi plus 0.955, you get 4.097, and the last one is going to be 2 pi minus beta, 2 pi minus beta. So 2 times pi minus 0.955. So you get 5.328. Okay, so let's look at the next example. We have tangent square x minus 4 tangent x minus 5. Okay, so if you think that tangent x is equal m, okay, so then you get m square minus 4m minus 5. This is just a regular, look like a regular trinomial that you can factor, right? You can use this changing the variable, or if you can see that, you know, you can factor it directly, so you don't have to do this changing the variable thing here. So I'm gonna do that. So tangent x, so we need to put negative 5 here and positive 1 here. Okay, if it is harder for you to see, so think it in terms of m square minus 4m minus 5, factor it and replace at the end m back with tangent x though, right? Okay, so what do we get here? We get tangent equals negative 1, tangent x equals positive 5. So now we will have to solve these two separately. Okay, so then get the beta for the first one. So tangent beta is going to be positive 1, and beta, so let's call it beta 1 because now we're going to have another beta there. Okay, beta 1. So there's a special angle which is 45 degree or pi over 4. So beta 1 is pi over 4. Then check where tangent is negative. Tangent is negative in quadrant 2 and in quadrant 4. Okay, then x is going to be pi minus beta, so 3 pi over 4, and 2 pi minus beta, 7 pi over 4. Now let's look at this one. So we are going to do tangent beta 2 equals 5. So this is not a special angle, so we have to do tan inverse 5. So that gives us 1.373. So beta 2 is 1.373. Okay, so let's sketch this angle again. So tan x equals positive 5. So we need to check where tangent is positive. So looks like quadrant 1 and quadrant 3. Okay. So x is gonna be beta itself, which is 1.373, and the other one is going to be pi plus beta. Okay, so pi plus 1.373, so we get 4.515. 4.515. So you have 4 solutions. So for this kind of questions, whenever you see that you can get special angles, okay, so you should do that. If it is not possible, then you get an approximate value for the angles. But if possible, then you get exact. Okay, next one. So 3 cos square x, cosecant square x minus 2 cosecant x minus 1 equals 0. Okay, so you may want to directly change it to sine, but actually if you factor it and then replace cosecant with, you know, 1 over sine, that's easier. Okay, because we see that again you have a kind of a trinomial here that you can factor. So let's factor it, get cosecant x, and then when we are solving, we are going to replace it by sine x. Okay, so if we factor this, so 3 cosecant x negative 2, so we are going to put negative 1 here and positive 1 here. So we get cosecant x equals negative 1 over 3, cosecant x equals 1. Okay, now sine x then, so flip those fractions, so you get negative 3 and 1 over 1 is 1, so 1. So sine x equals negative 3 again, so the range is between positive 1 and negative 1, right? So you cannot have sine x equals negative 3. So this part will give you no solution. Okay, but this one, if sine x or cosine x equals 0, negative 1 or positive 1, we use unit circle to solve. Okay, so remember this. So the coordinate of this point is 0 and 1. First coordinate are cos, second coordinates for sine. So now we see that sine of 90 degree is 1. So then x equals 90 degree or pi over 2. It's one solution. Okay, moving on. Last two questions. Okay, with the previous questions, we were able to factor them because they all had the same variable, like cosecant x or tangent x. But now we look at this, not only we have cos x and sine, cos and sine, but also look at these inside, right? So this is 2x and that is x. Oh, sorry. Yeah. So that is, as you see, one is cos, one is sine. Not only that, look at the angles, 2x and x. They are also different. So looks like we have to do something else first, so that we have only one variable here, either sine x, either cos x, or something like this, right? So what are we going to do? We are going to use our double angle formulas. Cos 2x. It has three formulas again, but which one we should use here, right? If we use first one, then we will have cos square x, sine square x, and sine x. Looks like not very good, right? If we use the second one, then we will have cos square x and sine x. No. If we use the third one, we will end up with sine square x and sine x. Then we can do something. Okay, so let's do that. So we are going to replace cos 2x by 1 minus 2 sine square x. I'm also going to move 7 to the left. Now distribute this. So you get 3 minus 6 sine square x plus 10 sine x minus 7 equals 0. So negative 6 sine square x plus 10 sine x minus 4 equals 0. Now we are going to factor this, but we see that 2 is a common factor of those two terms. Also, you don't want to have negative leading coefficient. So let's factor out negative 2 then. You get 3 sine square x minus 5 sine x plus 2. Okay, so let's factor this trinomial. 3 sine x, so you can divide both sides by negative 2. and then you just factor down this trinomial. Okay, so 3 sine x sine x. So we should put here -2 +1. Then we get sine x equals -1/3. Sine x equals +2. Again, sine x cannot be greater than 1. So this part will give you no solution. Oh, there's something wrong. Yep. So negative. Alright. So this is gonna be -2. This is gonna be -1. Okay. So you get sine x equals 2/3, and sine x equals 1. Okay, now we are good. -2, -3, -5. Yep. This is good. Okay. So then let's solve this. Okay, so sine x equals 1. We already solved it for the previous question. You can use unit circle and you get x equals pi/2. So this is one solution. So now we are going to solve sine x equals 2/3. So we can say sine beta equals 2/3. Then beta is sine inverse 2/3. So we get 0.730 or 73. Okay. Then sine is positive in quadrant 1 and quadrant 2. Then x is going to be beta itself and also pi minus beta. So which is pi minus 0.73. It gives you 2.41. So you have three solutions. One is here, pi/2. The other one is 0.73. And the other one is 2.41. Okay, so you can try the last one.